Hi everyone, Krishna this side. So in this video, I'll be covering this Leetcode problem 2294 partition array such that maximum difference is k. Okay, so you are given an integer array nums and integer k. You may have partitions of num into one or more subsequence such that each element in nums appear exactly one of the subsequence. Okay, so yes, we have to make sure this nums array we can partition in more subsequence so that elements shouldn't be appear more than once. Okay, return minimum number of subsequence needed such that the difference between the maximum and the minimum value in each subsequence is at most k. The subsequence is a subsequence that can be derived from another subsequence by deleting some or no elements without changing the order of the remaining elements. Okay, so if we look into this example 36125 and the k value is basically given 2. So yes, we have to create subsequences in a such a way that the minimum element that we picked in a particular subsequence and the maximum element that we got, the difference between those two elements should be less than or equals to this k value. So let us try to pick elements. So let us suppose 3 is something we picked. Then if we try to pick 6 into the same subsequence, can we put it? So the difference between 6 and 3 is basically greater than this 2, correct? So we cannot pick this 6 into the first subsequence. Can we pick 1? So now the difference between 3 and 1 is basically 2. Okay, so it is actually matching with this one. So yes, we can pick this one. Can we pick 2 into the same subsequence now? So yes, because the maximum value was so far what we got 3 and the minimum value was 1. So these two can be easily feasible and fit inside that one because we have to get the difference between maximum and minimum element, and any elements which are in between the maximum and minimum, those can be easily adjustable in that particular array. So yes, 2 we can pick it. Can we pick 5 now into the same subsequence? No, because now the minimum element was 1 and new maximum element that we got was 5. So 5 minus 1 is basically equals to 4, and which is getting more than this case value. Okay, so yes, the first subsequence that we could able to create is 3 1 2. And what are the remaining values now? 6 and 5. So we can try out with those things. Now 6 is the element that we pick. Okay, and the next one is like remaining was 5. So can I put 5 into that group? So 6 minus 5 is basically equals to 1, which is actually less than or equals to this value that we have. So yes, 6 and 5 we can keep it another group. So now what next? Do we have any remaining elements into this particular array? No, we don't have any remaining elements into this one. So yes, we could able to create two subsequence, and that is the answer that we have to write into the output. Okay, apart from this, do we say any other possibilities? So we have to make sure that minimum subsequences are something what we have to create. Okay, here, so we could able to create two subsequence only at the lowest. Okay, so more than low we cannot go further. Okay, we cannot pick 5 or 6 and put into this particular group. Even if 5, let us suppose, was possible, if k value is basically equals to 4, 6 cannot be placed into this one, and 6 could be another separate subarray. Okay, subsequence that we can create. So that way also it is possible, because if we look into this particular example, 1 and 2 can be put into one subsequence, but 3 cannot be adjustable into this one. So we put 3 separate, because the k value is basically 1, and if I try to put 3 in this one, 3 minus 1 is basically equals to 2, and we are going out of this case value. Okay, so here also two subsequences are possible. Okay, so yes, the idea is now we are getting like what we are actually trying to do here. So we have to make sure we create minimum subsequence as possible as we can create. Okay, and whatever the differences between the minimum and the maximum value that we got into that subsequence should be less than or equals to this case value. Okay, so now just tell me, if we start picking random elements, okay, let us suppose if I try to pick 1 and 6 and try to make a group, is it even possible? Just see here, if we subtract these values, because this is the maximum value that we got into this array and this is the minimum value that we got, 6 minus 1 is basically equals to 5. Okay, so is it even possible to create such a group which is having a big value, and I try to put it into the smallest group that is there, because 1 is actually the smallest value and 6 is the maximum value that we can get it from this array. So these values we cannot place it in one single group, right? So yes, the difference between any two elements that we are trying to pick should be minimum, and that is going to possible only when if the array is basically sorted. Okay, because see, if I sort this data now, 1 2 3 5 and 6, it is always possible that difference between 1 and 2, these addition elements, always less than this 1 and 6 or 1 and 5, because any two addition elements difference is always less than we can start picking the first and the last, or the second last, or the third last, right? So now 2 and 3's difference is always less than this 1 and 3, correct? So yes, if we sort the data, we can easily get the minimum differences between the addition elements. Okay, the next question is whether we have to pick these two elements if it is matching this value or not. That is the particular thing that we have to figure out. Okay, let me just quickly connect. Now the first thing is we already solved, like we just have to sort the data, because the difference between the addition elements should be minimum. Whichever the elements that we are picking, it should be minimum. So it is really required that this data should be sorted in order. Okay, now let us just focus into the screen. Okay, so see, let us suppose now we have the same example, 1 2 3, it was 5 and 6, and k was basically equals to 2, or yes, k was basically equals to, so instead of 2, let us take it is as 1. Okay, now what we can do is, see, the difference between the addition elements are minimum. That is something what we got once the data has been sorted. So yes, we got the sorted information now with us, and we will try to create the pairs. Okay, the subsequence of arrays is something what we are trying to create, and it should be minimum. So yes, if we want to create a minimum subsequence, we should try each element if it is able to fit. Okay, let us suppose, uh, let us say that the k value is basically 2 for now. So we have to make sure that maximum elements should get fit in the particular array. Okay, whatever the subsequence that we are trying to create, the maximum values we should try to adjust in a particular array. Let us suppose here 1 and 2 are possible. Now I thought that okay, 3 I can place it in another group, even though 3 was able to fit into this one. Okay, so yes, we have to make sure that no element is getting left out until and unless the subsequence itself getting out of bound with this case value. Okay, whatever the k value that we got, if it is getting exceeded, then only we will try to shift the element into the next subsequence, or we can create a separate subsequence for that one if it is not able to fit in any of the group. Okay, so again we will go back to this k values as equals to 1. Okay, and let us try to create the groups now. So what we can do is, the idea is pretty much straightforward. We have to create the maximum size of arrays group. So first what we will do is, we will create a pointer right over here, which will be previous pointer, and we will create a count so that we can keep on counting how many pairs are there. Initially the count is 1, because I am considering this, if this particular one, if it is not a part of any group. Okay, in the future, so the count should be actually started with 1. Okay, that's why I initially started with the count 1. And what we will do is, we will start pointing from here. So our next pointer is basically pointing from here. Okay, so two pointer approaches simply we will use here. So what we will do, we will keep on checking next minus previous. Next minus previous, something we will check if the difference between next and minus previous, if it is actually less than or equals to this case value that we got, so we will directly shift our next pointer. Okay, so now difference between 2 and 1 is basically equals to 1, and it is actually equals to case value. So yes, the next pointer will get shifted from here to here. Okay, now we will check again. So minimum and the maximum values difference is something what we have to keep on checking. So the first previous pointer is basically pointing always to the minimum value that we can get it. Okay, so now the next pointer is here. So 3 minus this one is basically equals to 2, which is actually greater than this case value. The moment we get that this case value is actually getting out of bound, what we will do, the previous will get shifted right over here. Okay, easy. And the next pointer is basically always it is going to point to the next element, it as it is. And the moment the previous pointer is getting shifted, the count will get incremented, because now the one group is something what we able to create. Now from here third onwards, we will try to create another groups. Okay, so this previous this whatever the previous is pointing, it might be individual element as well. Okay, or this is the last element that is available in the array. So definitely this was the first group and this was the second group that we can say, right? So yes, now the counter got incremented to 2. The previous is basically now pointing to the 3, and next is basically pointing to 5. Again we will check next minus previous in the next point. So it is like 5 minus 3 is basically 2. Again it is greater than k. So yes, of course the previous should get pointed to 5 now. Okay, and the counter should get incremented. So what happens, this was the first group that we created. Let me change the color. This was the first group that we created. This was the second group, because 5 minus 3 is not giving us value less than this k. Okay, so that's why we shifted our previous 2, now 5. Next will get shifted to 6. because next is something like a for loop that we are creating, and we are keep on checking each index if it is feasible into previous group or not. Now 6 minus 5 is something we will do. It is basically equals to 1. So yes, if it is basically less than or equals to this k value, that is going to be another group, because this is the group that we can form. And the counter was basically 3, and we end of this group. So counter will not get incremented because this 5 and 6 could able to create a pair. So the previous was basically pointing to 5 itself, and counter was already updated as per that value. Okay. So if any value that is formed with the whatever the previous pointer that is pointing, we shouldn't have to worry about the counter. Okay. It is like this is how we can write this code. It is pretty much straightforward. Let us try to write the code now. And yes, if we have solved yesterday's code, it is going to be the same one. Let us just quickly sort the array. We can use count sort as well, because again here the nums of I is basically 10 to the power of 5, and that way we can reduce the complexity from n log n to n. So yes, we can do either of the way. I actually said wrong info. I provided wrong information yesterday, and I noticed that I am not verifying whatever I try to say before making any videos, and I'll make sure that any information that I am passing, it will be verified first, because I just said randomly yesterday, and the value shouldn't whatever the n log n value that we get, it is actually uh, a bit higher than 10 to the power of 6. Okay, we will not go to 10 to the power of 8. And also in the previous videos I have noticed that I may get confused sometimes this both the operators, if it is this left shift operator or right shift operator, but I know that how these operators basically works. So yes, this was basically a right shift operator, and I usually get confusion, but I know that if we are having these operators, we are actually dividing it. That means digit is actually getting out of from this zeroth index whatever we have, and this is basically left shift operator, but I usually get confusion by naming them. But yes, before making any videos, I'll make sure that whatever the information that I am passing, it should be correct. So let us sort this data, arrays dot sort nums, and then the next thing is like we'll run a loop. Before that, let us create a counter. Basically counter is basically 1, and int previous, the previous pointer is basically nums of 0. Okay. So if previous value whatever is there in the nums of 0, if it is not matching with next one to create a pair, so of course the counter should be 1 for that case. So we are starting the counter with 1, and we will start looking from this first index onwards, because the zeroth index we already considered as previous one. And nums dot length, the next is I plus plus. Here what we do is basically we'll check that the basic thing, nums of I, whatever the value that we have, and the previous value, if it is actually greater than the k. The moment we see that if the value is actually greater than the k, what we do, we simply change this previous pointer to this nums of I. Okay, that is the thing that we were doing, and the counter will get incremented. That's all. These are the things that we will do. Apart from this, do we have to perform any operations? If less than or equals to k, we will keep on incrementing this i's value. The next pointer is keep on getting incremented, so we have to do nothing in that particular case. Okay, the moment we get the counter, we will simply return it. Okay, it is pretty much straightforward. So yesterday, if you have solved yesterday's problem, there we were trying to create three groups, and we were checking the first and the last elements difference. Here we can include further more elements into the same sequence. Okay, so yes, that is about this particular question. Let us submit this code as well. And talking about the complexity, it is going to be n log n, and the space is basically we are not utilizing any space. And yes, and the for loop is this, it is going to be big O of n. So n plus n log n is the complexity that we get. Okay, that's all from this particular video. Thank you for watching this one. Bye bye.